All right, we're going to start Unit 3, which is a pretty big unit as well. We start this off with factoring. And what we're going to do today is factoring by GCF. So hopefully you remember that GCF stands for greatest common factor. Now, keep in mind that that doesn't mean the largest, it means the most. So the greatest common factor is the most that two things have in common. What we're going to do when we factor with GCF is we are going to be working with polynomials again. So this is going back to Unit 1. And what we are doing is basically what I would call backwards distributive property. So if you remember from Unit 1, we would take the number outside and distribute it to the rest. Well, what we're going to do now is we're going to have the answer and we're going to write it as the distributive property. So we're going to start off pretty easy and then work up. Alright, so first thing, let's say we had 6n plus 9. When I look at this, this is a binomial because there are two terms, and I notice that I can divide both of those by 3. So I'm going to write 3 on the outside of the parentheses, and then what's going to go in here is what I need in order to end up with a 6n. So I would need to multiply by 2n, and then what would be left over here in order to get a 9 would be a plus 3. So the way to check is if I distribute this 3, I would get 6n plus 9. So that's it. So that would be the answer. So it's actually pretty simple, not too complicated. All right, for another one, let's say we had 3n squared plus 12n minus 9. You can have 3 terms. This is a trinomial. So I'm going to look for what's in common. And I see that I can divide all of those by 3. And if I divide everything by 3, I'm going to put the leftovers in here. So what I need in order to get 3n squared would be an n squared. What I would need in order to get a 12n would be a positive 4n. And what I would need to get a negative 9 would be a negative 3. And basically what I'm doing is I'm dividing each of these by the 3. So if I distribute that, I get 3n squared. If I distribute here, I get 12n. And if I distribute there, I get negative 9. So this is the factored form of that. So it's basically, like I said, backwards distributive property. All right, now your greatest common factor can involve variables. So let's say we had 4x cubed minus 6x squared plus 20x. Alright, when I look for a GCF out of here, I can see that the 4, the 6, and the 20 can all be divided by 2, but I also see that they all have an x in common. So if I divide each of these by 2x, then I know in order to get 4x cubed, I need a 2x squared. Because remember, when we multiply, we add exponents together. And if I need a negative 6x squared, this needs to be a negative 3x. Because when I multiply those together, I'll get negative 6 and then add the exponents for x squared. And then for this one, it would be a plus 10. So the way to check is if I distribute that, I get 4x cubed. If I distribute here, I get negative 6x squared. And if I distribute there, I get positive 20x. All right. It is also possible to have a negative as your GCF. So, let's say we had negative 42m cubed minus, we'll do negative 7m squared plus, we'll say 14m squared also. So this probably isn't a good problem, but I think it'll make sense in a second. I can divide all of these by 7. And since the first one is negative, I'm going to take out a negative 7. And then when I look through, I see that they all have at least m squared. So if I want to get back what I started with, I would need to multiply negative 7m squared to a positive 6m. I would need to multiply negative 7m squared to a 1 in order to get negative 7m squared. And I would need to multiply a negative 7m squared by a negative 2 in order to get a positive 14m squared. And so that is the solution. Alright, for our last example, I want to show you that it's possible to have just variables as the GCF. So let's say we had C5 D4 plus 3 C4 D3 minus 9 C cubed D squared. Alright, so when I look at this, those two can be divided by 3, but this one can't. But they all have a C, and in fact, this one has C to the 5th, this has C to the 4th, this has C to the 3rd. So they all have at least C to the 3rd. And then when I look at the D's, this one has 4, this one has 3, this one has 2. So they each have at least 2. So now, if I write what's left over here, in order to get C cubed D squared to become C to the 5th D to the 4th, I need a C squared and a D squared. In order to get this one, I would have to multiply by 3 C D. And to get this one, I would need to multiply this by a negative 9. And so that is the solution. And again, all of these you can check by just working through the distributive property. So now if you need to replay it, please feel free, but you can go ahead and pick up today's worksheet and get started on that.